Okay, this problem gives us a concave mirror with radius r, and it tells us that there's an object that's placed in front of that mirror, and the image must be upright and 3 times the size of the object. It asks us then where would we place an object to get this result? Where would the resulting image occur? And then it asks us to describe the resulting image. Is it real or virtual? So let's check it out. In this case, we're working with a concave mirror, and the mirror equation, which I have over here in blue, it applies to any situation here. What we have to remember about a concave mirror, though, so this is a concave case. Whoop. What we have to remember about a concave case is, what do you know about the focal length? So you should be kind of getting to know this by now. We have a positive focal length for a concave mirror, right? All right. So what they're telling me, or another thing that I know, I guess, about this is I'm given the radius of the mirror. I know that the focal length is equal to half of the radius for a spherical mirror. That will always be the case. So I have that now in terms of a given. And they've also told me that the magnification is equal to 3, right? Magnification. And the image is upright. So I know that the magnification is equal to positive 3. So I right away in these optics problems, when you're told this information, try to put it down in some type of equation that will help you. And these equations are kind of small and they have to, be fitted together, but it's still important to have them on your paper. So the magnification equation in general, I'll write it over here in general, is m is equal to negative image distance over object distance, remember? So let's use that now for our particular case. So we have here that positive 3 then is equal to negative q over p, and that gives me this relationship, q equals negative 3p between q and p. That's pretty useful. And the mirror equation involves both q and p, so that's the place that I want to use this relationship. I'm going to take the mirror equation and I want to solve for q. So my first move is just going to be to isolate q in this equation. When I solve for q, I get product p f over p minus f. You want to be sure you're comfortable doing that. So that is what I'm going to apply to this particular part here. So I'm solving for q. Q is equal to pf over p minus f. Got it. But q is equal to negative 3p, right? I figured that out up there. So I can set that equal to negative 3p. Nice. Now look what happens there. I get that f over p minus f is equal to negative 3. F is equal to negative 3 times p minus f. And what this brings me to, finally, is that 2f, a little bit of algebra, is equal to 3p. All the intermediate algebra steps are found in the written solutions. So this is useful. This tells me that p is equal to 2/3 f. And I know that f is equal to r over 2, so p is equal to r over 3. So this is my object distance, which is one of the things that's asked for here. Where must you place the object? So then we can easily find the image distance because we have a relationship between Q and P that's already established. Q is equal to negative 3P, so that is negative R. And so this is my image distance. The other part of the question asks, is it a real or virtual image? So whenever I have a negative image distance, whenever I have that, then the image is virtual. So it's virtual, and my justification for that is that Q is negative. So when I have a positive image distance, that notes a real image. When I have a negative image distance, that notes a virtual image.